We're up, we're painting fluid with code. So I'm Dave Trafford, and I saw this technical talk as some time that I could introduce something that I made, something that was technical in nature and a little bit hopefully different to what you might have seen before. I do want to raise that my work is heavily based on the work of a technical artist called Jos Stam, who was just a brilliant computer engineer. This is my goal. I want to create artwork without having any assets, any artwork at all. This is something I want to make using only code. So what I'm talking about, of course, is shaders or shader equivalents, texture mapping, doing a lot of stuff in this sort of space. And to be able to do it in a way that's also dynamic, the player can interact with it, and it real-time usage. But I'm getting ahead of myself. I wanted to talk a little bit about how we got there. So this is my pixel. And as a pixel, I can store a lot of information in this. If you're familiar with technical art, you can understand where I'm kind of going with this a little bit. But for this pixel itself, I put velocity. It's a movement and a direction, a direction and a speed, and it can store that information. Very boring. Doesn't really do anything. This is a very dry PowerPoint. It gets a lot more interesting when we start adding the pixels around it, because it cares about its neighbors, it cares about the things that they're feeling, how much it feels towards its neighbors, how they're impacting on them, and how much it should care about it. And this is where Jos Stam's work really got involved. And he started working closely with what's called the Navier-Stokes equations. The Navier-Stokes equations are these ideas of how fluid moves in real life. Now, they are notoriously difficult to model because it's fluid in motion, and I don't just mean fluid like water running down some rocks. I mean gases, anything that's considered what's referred to as a Newtonian fluid. Now, with this, what we can do is we're making games, and if anyone's done anything in coding, especially into physics, we know that games likes to cheat. And that's what we did. We simplified all the maths. We took out that time step. We didn't make it this infinite thing that's caring about fluids across everywhere and everything. We made it simplified. We made it something that can run on the GPU and that loops in on itself. And these four things are the four things that we care about the most: the advection, the diffusion, external forces, and viscosity. And I know this is dry, but bear with me because it gets better. The advection, how it moves through the space. Diffusion, that's like how it's kind of filled. Think like a smoke filling out a room. Viscosity, is your fluid a syrup or is it a gas? And then external forces, that could be anything. That's where we start messing with what's going on. That could be mouse input, that could be a player dashing through, that could just be that you have a consistent wind factor going on. You put all this together, and then you can use that to create something really interesting. Now, all of this is all code. There's not a single art asset that exists in this whatsoever. This is taking these laws, these Navier-Stokes equations, applying the work of Jos Stam, and creating something that can interact with its environment, that it can explode around the room, and hopefully make something really great. Now, you can use this to make smoke, to make particles, to make honey flowing down. What was that game that was huge in the last year? Bears with guns? Bears in space? Space guns? I'm going to murder it, but stuff like this. Imagine a particle, a magic spell shooting across, and it's just screaming across your screen, and it looks like this, reactive to its environment and exploding everywhere. Thanks so much.